this is Charlene. We are going to solve and graph this inequality. So our problem says that we have 10 times parentheses a minus 3, close parentheses, minus 13a, which is less than or equal to 9 times a minus 8. The first order of operations says that we need to consider what is inside the parentheses. Can we do anything to what's inside the parentheses? No, we cannot, but we can eliminate the parentheses by dividing into or distributing into the parentheses. We're also going to do the same thing with the 9. We're going to distribute or multiply into the parentheses in order to eliminate them. So let's go ahead and do that right now. 10 times a is 10a, and 10 times negative 3 is negative 30. And we've got a 13a here, which we're just going to rewrite down here. And that's going to be less than or equal to 9 times a, which is 9a, and 9 times negative 8 would be negative 72. Okay, at that point, we just continue with order of operations and combining like terms. I have a 10a here, and I have a negative 13a there. So I'm going to go ahead and combine those two things. 10a minus 13a is negative 3a, and then I still have that negative 30 right there, so I'm going to bring it down. And then that all is less than or equal to 9a minus 72. Okay, continuing with order operations, continue to combine like terms, except now I'm going to move them across the inequality sign. So I'll move the 9a to the side with the negative 3a, and I'm going to move the negative 30 to the side with the negative 72. Because, let's see, this is an a term, this is an a term. But this is a constant and this is a constant. So we're trying to get all those like terms together. So the first thing I'm going to do is do minus 9a on both sides. Minus 9a. And that's going to give me 9, 10, 11, 12. Negative 12a minus 30 is less than or equal to, those canceled out, negative 72. Now I'm going to do plus 30 to move it to the other side. So plus 30 on both sides, plus 30. And now these will cancel out. I have negative 12a is less than or equal to negative 42. Okay, so now the next item that we're going to take care of is getting rid of this negative 12, which is being multiplied by the a. But when I divide by a negative, which I will do on both sides, when I divide by a negative, we've got a special event that needs to take place. I'm going to divide by a negative. That means I'm going to flip the sign, flip the sign. So the next thing is going to be a. Uh-oh, a looks a little funky there. So a, and flip the sign. This is going to become a positive on this side. So 42 divided by 12 actually equals 3.5. You can do that on your calculator if you need to. So just notice that we did flip the sign right there because we divided by negatives. Okay, so that actually is the answer to our inequality. So that's what we would list up here. A is greater than or equal to 3.5. Okay. So if we were going to do a set notation, which we're going to do the interval notation officially for this problem, but I wanted to just briefly talk about set notation. So S-E-T-N-O-T-A-T-I-O-N. Set notation, except that that T is too close to that N. So set notation. If we were going to do set notation, it just would be A such that a is greater than or equal to 3.5. So that's the only thing that you do to use what they call set notation. But we are officially going to do the interval notation over here in just a minute. So let's go ahead and graph our inequality. So there's my number line. And I'm going to, for fun, I'm just going to put a 0 right there. And then my 3.5, I'll stick it over here somewhere. And our inequality says that it could be equal to the 3.5. So that means I'm going to do a closed circle. I'm going to color all that in. Closed circle, it means it can be equal to the 3.5. So it says that they are greater than. Greater than, it's like big mouth means greater than. So is it going to go this way if they're greater than, or is it going to go this way if it's greater than? Well, it's going to be this way if it's greater than 3.5. So all of my A's will be over here in this section of the number line. So that is my graph right there for my inequality. So, but this number line actually helps us to think about our interval notation, because basically the interval starts right here. It starts at 3.5 and it goes this direction forever and ever and ever, and the math symbol that represents forever and ever and ever is infinity. So that's gives us what we need for our interval notation. It's going to start at 3.5. The hard box, that's what I call this. Hard box means it can be equal to the 3.5, so it starts at 3.5, and we put a comma, and then we're going to put where it goes. Well, where does it go? It goes to infinity, but it can never reach infinity. We can never actually get there. So I put a parentheses, which is what I call the soft close, because we can never actually touch infinity. Okay, that would be the final part of our inequality. This is your graph. This is your interval notation. Hope that helps.